Hi, I'm Jessica, and welcome to our second video in our crash course on solving algebraic problems. This video is really meant for students in Secondary 2, but if you're in Secondary 3 or older, you might find it to be a useful refresher. You might remember from our first video that we looked at a few problems and we followed the 5 following steps. We always follow these steps when we're solving algebraic problems. We need to first define the variables, write the equation, solve the equation, verify the solution, and then give a complete answer. So in this second video, we're going to be looking at problems that are more difficult than what we saw in the first video. And we're really only going to focus on the first 2 steps to complete those problems. Actually, we're not really going to complete the problems. We're just going to focus on the first 2 steps because those are the most complicated steps. After that, solving should be a little easier for you guys. So let's get started. All right. So let's take a look at our problem here. It's actually problem 4 in our series, and we're dealing with cars and motorcycles. So let's give it a read. A mechanic needs to change the tires on 40 vehicles, both cars and motorcycles. In all, 152 tires need to be changed. How many of each type of vehicle, cars and motorcycles, are there? So our first step is to define the variables. Before we do that, though, I have a little question for you. True or false? There's not enough information to solve this problem. If you answered false, you are correct. There actually is enough information, but sometimes, like in this problem, we actually have to draw from our knowledge from our outside experience. So in this case, we're going to have to draw on the fact that we all know that motorcycles have 2 tires and that cars have 4 tires. So we're going to use that to help us in our building of the equation. So first, let's look at how do we actually define these variables. I'd suggest you set up a little table like this. That will just help us organize our thoughts a bit. And I need to decide whether or not my motorcycles is going to, or the number of motorcycles will be defined as my X, or whether the number of cars will be defined as my X. In this case, I'm going to use motorcycles as my X. And there's no real particular reason behind that, just that that's what I decided to do. So I'm very specific. You notice that it really is the number of motorcycles. I haven't talked at all about tires yet. It's just the number of motorcycles. That is my X. So right here in the total column, I know that I had 40 vehicles. So I'm going to put 40 in the total because my total number of vehicles is 40. That brings me to defining my cars. Well, if I know that I have 40 vehicles total and X of them are motorcycles, then cars can be found or represented, the number of cars can be represented by 40 minus X. Had I decided to put X as my number of cars, well, then it would have been the motorcycles that are represented by 40 minus X. So it would change a little bit, but ultimately I'd be going through the same thought process here. Now let's talk about tires. So the number of tires on motorcycles, that's 2. So I'm just going to write a 2 here below. Okay, and the number of tires on a car is 4. So I want to put that here. And I know that my total number of tires is 152. So I'm going to put that here. My second step is, of course, writing the equation. Right? So I'm going to do that using my first line of work. Well, I know that I have X number of motorcycles and I have 40 minus X number of cars. So if I add those 2 statements together, it's going to equal 40. Well, I think you can quickly see that this doesn't really get me any further in terms of figuring out how many of each type of vehicle there are. Because if I start to solve this, well, X minus X is going to give me 0. And quickly I get 40 equals 40, which hasn't really advanced my problem. How do we advance the problem? Well, remember we talk about tires here. This is where we got to start incorporating this notion of the number of vehicles with the number of tires on each vehicle. So in order to do that, I'm going to take the number of tires that motorcycles have, and I'm going to multiply it by the number of motorcycles. And for cars, I'm going to take the number of tires that cars have, and I'm going to multiply that by the number of cars. And my total number of tires will still remain 152. Now, if I take a look at that in terms of what that gives me as an equation, you can see that here I've taken the statement that represents the number of tires on motorcycles, and I've added that to the statement that tells me the number of tires on cars. And setting it equal to the total number of tires. So this first equation, I'm just going to cross it off because that's not the one we want to solve. We've got it because we needed to incorporate it into the second line of work to be able to actually create a useful equation that will lead us to solving how many of each type of vehicle we have. So now it's just up to you to finish solving this problem. If you get to 4 motorcycles, you know that you're on the right track. So for our 5th problem in our series, we're going to deal with age, and we're going to take a look at Clovis and his father, Jim. So Clovis is 1/4 of his father, Jim's age. In 16 years, Jim will be twice his son's age. How old will both Clovis and Jim be in 16 years? So the first step is, again, to define the variables. And to help us organize our thoughts, I'm going to propose another little diagram for you. Set it up just like this. And you see that I've got it already organized into the idea of Clovis's age and Jim's age both today in the first line of work and in 16 years in the second line of work. So the decision is now, do I make my variable Clovis's age today or Jim's age today? And really, I have the option. So let's just explore how that would look, starting with Jim's age. So if I take Jim's age today and I define that as my x, then Clovis is 1/4 of Jim's age today. So that would mean that to get Clovis's age, I'm going to have to divide Jim's current age by 4. And that would give me x divided by 4. Now, I've said in previous videos and statements that I kind of prefer to stay away from dividing if I can. All right. And since I have the option here, I'm going to take a look at what that would give me. All right. So I'm just going to erase this and look at it through the lens of defining Clovis's age today as my variable. So if I do that, that would mean that Clovis's age is my x. And since Clovis is 1/4 of his father Jim's age, it means that Jim is actually 4 times Clovis's age. So I can get Jim's age now by multiplying Clovis's age by 4. So that would give me 4x for Jim's age today. So I'm happy with this. I'm going to leave it like this. I'm choosing to define Clovis's age today as my x. Now the blue arrows that you see here are how they relate to their ages in 16 years. So if I want to age both of these guys by 16 years, I've got to think about how I myself would age or represent my age in 16 years. So I'd take my current age and add 16 years to it. So I'm going to do just that for Clovis. I'm going to add 16 years to his current age. And I've got to do the same thing for Jim because Jim is also getting older by 16 years. So what that's going to look like for Clovis, Clovis's age in 16 years can be represented by the statement of x plus 16. And Jim's age in 16 years can be represented by the statement 4x plus 16. It's a little low, but I think it's still making it in there. All right. So I've got these initial statements, but I still don't really have an equation for this. And I'm also not really finished with everything that my problem has told me. So let's take a look at what else is in this problem. It says that in 16 years, Jim will be twice his son's age. So to represent Jim in 16 years, I have one statement already, but then I also have this one that's telling me that he will be twice his son's age. So I have an option of taking Jim's age and dividing it by 2 to give me Clovis's age, which I guess would give me Clovis's age in 16 years. But again, I would prefer to go through multiplication. So I've got to think of that as well. Jim will be twice his son's age. So if I take Clovis's age in 16 years and multiply that by 2, then I get another statement about Jim in 16 years. And that would be 2 times Clovis's age, x plus 16. Okay, so that seems a little weird to have 2 expressions written in one box like that. But actually, it's pretty useful for helping us to write the equation, because if I take a look at these 2 statements, what they're saying, in the first hand, it's talking about in 16 years, Jim will be twice his son's age. So I have Jim's age in 16 years represented by the statement 2 times Clovis's age, or 2 times in brackets x plus 16. And then I also have the second statement, that 4x plus 16, which we remember was Jim's age to date plus 16 years. So it's a second way of representing Jim's age in 16 years. So both of these statements represent Jim in 16, or Jim's age in 16 years, and they are equivalent to each other. So just think about what that means. That means that the statement 2 times x plus 16, which is twice Clovis's age, is equivalent to 4x plus 16, which is Jim in 16 years. And now I have an equation. I have a left and a right side, and I can go ahead and solve for x. So in solving for x, remember, that would actually give me Clovis's age today. So if you got Clovis's age today as being 8, then you know that you're on the right track to go ahead and solve for the rest of the problem, which is how old will both Clovis and Jim be in 16 years. So I'm going to let you guys go ahead and do that now that everything's set up for you. All right, so for our last problem, which is problem number 6, we're going to be dealing with numbers. The problem states the sum of 3 consecutive odd numbers is 237. What are the numbers? Once again, we start by defining our variables. And this time, since we have 3 numbers that we have to concern ourselves with, I've got a spot for the first number, the second number, the third number. And I've also included the sum here because even though that's not a variable, we know that number, we know that it's 237, it appears in my problem. It still helps me to have it written here. So I'm going to write that right there. The sum is equal to 237. All right. So to define the variables, I'm actually going to use the letter n this time because we're dealing in numbers, so it works. And I'm also dealing with consecutive odd numbers. So that means that I'm looking for odd numbers that are in sequence with one another. So if I start by defining my first number as n, then I can get my second number by adding 2 to that number. So that means that if I take n plus 2, I can represent my second number. Finally, the third number, I'm going to find it the same way. So, but this time I'm going to add 2 to the second number. So to find my third number, I'm going to take the second number and add 2 to that. This can be simplified. The numbers are like terms, so I can actually add the 2 2's together to give me the statement n plus 4. Which is ultimately what will represent our third number. So now I'm ready to go ahead and write my equation. And to do that, I've got to think about what it means to be a sum. Well, the sum is the result of an addition. So really, I'm going to take the 3 numbers and add them together to give me 237. So the first number plus the second number plus the third number will give me 237. But remember, I've got these algebraic statements or expressions that I've used to represent each of these numbers. So really what I'm going to be using to solve the problem is n plus 2 plus n plus 4 equal 237. So I'm all set up with my equation. I'm ready to solve for n, but I'm going to let you guys go ahead and do that. What you need to know, though, is that if you get one of your values as 81, then you know you're on the right track. So that brings us to the end of our crash course on solving algebraic problems. In the second video, we really focused on the first 2 steps of solving an algebraic problem. But if you need a refresher on how to solve an equation, then don't forget we have a video on just that for you. There's also some exercises linked to this video, so don't forget to check those out if you need some extra practice. Until next time, I'll see you guys later.